This is a continuation of Lesson 7.3, where we're learning how to conduct a hypothesis test for a mean. We know that we're following this process where we first verify that the standard deviation of the population is not known, and hence we use a t-distribution instead of a normal curve. Also verify that the sample is random and that either the population is approximately normal or n is large. Second, we state the claim and mathematically and verbally and identify the null and alternative hypotheses. Third, specify the level of significance that's given in the stem of the problem, and that would be our alpha. Fourth, identify the degrees of freedom, which is one less than the sample size. Fifth, find the critical values, and then the rejection regions will be out beyond them. That's six. 7, calculate our standardized test statistic using the formula given. Then 8th, make a decision to reject or not reject the null hypothesis. And then last, identify what that means about our claim in the context. Do we have evidence in favor of or opposed to the claim? So let's try with this first example. A used car dealer says that the mean price of a 2-year-old sedan is at least $20,500. At least means greater than or equal to $20,500. Well, since there is an equal sign with that claim, that belongs in our null hypothesis. It's a claim about a mean, which is why I'm using mu. So our null would say that mu is greater than or equal to 20,500. We know that our alternative is the complement of that, which would be less than 20,500. So we can see that because of the direction of our alternative here, less, this is going to be a left-tailed test. We read on and it says you suspect this claim is incorrect and find a random sample of 14, so n is 14. Similar vehicles that have a mean price, that's our sample average, so that's our x bar, of $19,850. Notice it's less than what is claimed. And a standard deviation. Now that's the sample standard deviation, so that's S, 1,084. Is there enough evidence at the dealer's claim at alpha equal to 0.05? Assume the population is approximately normal. And that statement is important because n is not large. 14 is not 30 or more. Okay, so we've already identified the claim mathematically as well as in words, written our null and alternative hypotheses. Okay. We also want to identify that sigma is not known, and it is not. We know S, the sample standard deviation, but not sigma. We've specified a level of significance equal to alpha, which is 0.05 in this case. Our degrees of freedom would, of course, be n minus 1, which would be 13 in this case, since n is 14. All right, so now we're going to move on to finding our critical values, our rejection region, and all of that. So what we need to do is go to our table 5 for the t-distribution. Go to the row at the top, for one-tailed, because this is a one-tailed test. It's a left-tailed test. And find the alpha level of 0.05. If you go down to the degrees of freedom equal to 13, you should see a critical value of 1.771. But because we're doing a left-tailed test, then that needs to be negative. And so you can see that I have gone out in this drawing little less than 2 standard deviations below the center of the distribution and marked a vertical line at that critical value of negative 1.771. Okay? So what I need to do next is find the rejection region, and in a left-tailed test, that would of course be the area below that critical value. So shaded in blue, you see the critical region. If our test statistic lies in that critical region, we're going to reject the null. So let's calculate that test statistic next. Remember, it's x bar minus mu over the standard error, s over root n. Okay? So in our case, our x bar was 19,850. Our claimed mu was 20,500. Our standard error would be our S, the standard deviation of our sample, divided by the square root of n. And remember, when you calculate this, if you're going to do this all in one command on your calculator and then hit equals, you've got to enclose your numerator and denominator in parentheses. We get a test statistic of negative 2.244. Well, notice negative 2.244 is in that blue region. It is in the rejection region. So we are going to reject the hoe. Now remember, the hoe is what contained the claim. So we can say that at the 0.05 level of significance, there is sufficient evidence to reject the claim. Sufficient, sorry. That the mean price of a 2-year-old sedan is at least $20,500.